Hey guys, this is Rachit Jain. My effort through this set of videos is to ensure practical understanding of simple and complex concepts in the field of probability through college level rigorous mathematics but with school level ease. The agenda for this video would be to view the concept of conditional probability. We shall try to prove that it is a valid probability mapping, and later on we'll go on to see what actually is a null and impossible event. So without any further delay, let's get into it. In the previous video, we learned what the true definition of probability is. And today, let us jump directly into conditional probability. So as soon as we think of this phrase, we remember this formula, right? So what are the hidden assumptions that we are relying on? Let us use this Venn diagram and see what's the probability of occurrence of event A, given that event H has occurred. So rather than seeking for the probability of event A, we are looking for its probability only when H has happened. That is, within the region of H inside that figure, what is the chance of A happening? And that region is basically A intersection H. Thus, the conditional probability P of A given H is given by P of A intersection H over P of H, because that is the small area of A happening inside that region of H divided by the whole probability of H happening altogether. But we realize that for this, P of H should not be 0. Otherwise, this probability is not going to be limited to 1. And A and H should also be from the same sample space S. One thing to note is that if P of H is not greater than 0, then the conditional probability is not defined. However, it is not 0, it is not defined. But why are we calling this a probability itself? Shouldn't we first check those 3 axioms that we learned in the last video? So let's get into it. First, since P is a valid probability mapping, we can conclude that P underscore H is also non-negative. Secondly, putting the universal set in the formula, replacing A with omega, we see that P of omega intersection H becomes P of H, and that the denominator is also P of H, so the whole thing becomes 1. So this too becomes valid. For the third, we choose pairwise disjoint sets. Putting it in the formulation and going through the maths, we see that since these AIs are disjoint, their intersection with H would also be disjoint. You can visualize this using this figure. This boils down to validity of countable additive property as well, because the intersections are also disjoint, and when we work out the maths, their union of probability of unions becomes the summation of their probabilities, and that becomes actually a valid probability mapping. Now that we are certain that what we learned as a conditional probability is actually a probability conditioned on the occurrence of the event in the sample space, we move on to learning about the next concept called multiplicative law. See that P of A intersection B can be given by P of A given B into probability of B. This comes directly from the previous formula itself. But wait a second. When we say that P of A is equals to 0 or P of B is equals to 0 for that matter, what does that actually mean? Does it mean that it is impossible to have A would occur? Well, no. To understand this, we need to look at the minute distinction between a null event and an impossible event. So first, null event. It's an event A belonging to S that has the probability of P of A being 0, but A is not equal to the empty set itself. This means that A can occur, but probability of occurring is equals to 0. But it is possible that A can occur. Let us understand this a little confusing event with the example of archery. Suppose we define an event A as hitting the center of the dart in a single throw of an arrow. Let me ask you this. Is it impossible to hit the arrow at the middle? No, of course. What is the probability associated with it? Some 0.00001? Well, no again. Suppose this was the case, that the probability was some finite number but very, very small. Then this probability would be true for hitting any point on the dart, right? Why just the middle point? The number of points we know on the dart is infinite. Then infinite times any finite number, however small, becomes infinite. But P of A is less than equals to 1 as per the definition, we all know that. This is why it is not possible to say that this event would have a non-zero probability, however small it may be. Even though the event is possible of hitting the dart at the middle with a single shot of an arrow, but P of A is equals to 0, and this is called a null event. On the other hand, for an impossible event, it is an empty set itself. So A belongs to S such that A is equals to phi, and the probability of A, we all know that probability of phi is equals to 0, and that is the difference between null and impossible event. In null event, A is not equal to the empty set. It is possible, but for an impossible event, as the name suggests, A can never happen. So to sum it all up, we have the following takeaways from this video. First, we are now clear what is actually conditional probability and why is it called a conditional probability. Second, the difference between null and impossible event is subtle, but the distinction is important. Hope this video added some knowledge and value to your fundamental concepts in probability. In the next video, we'll try to understand what are independent events, and that is something what students are generally confused about. If you like the content, please don't forget to like the video and subscribe to the channel. Till then, stay healthy. Rachit Jain signing off.